Mhm.
When all of it's starting to feel like a real class. Good. And if there's just one,
Yeah.
like, oh shit. Your real intimate class.
Yeah. They're it was like leaving one-on-one like your office or something.
Yeah,
I was
right.
like,
It's like, this is me in my office every day, yeah. All right. I'm gonna turn the lights down a bit so you can see the screen better. Oh, wow. Right. What, if anything, do you remember from? We've got two new people here. Start with that. Introduce yourself.
I was so, I was in farming, I ran research has to do with DNA, so. I think it was one.
Jeff. I was an English major. Back in the day. Switched over. Yeah, so I am self-taught on all this. I've been doing it for like pressing a long time at this point. So what do we remember from last time? It seems like both of you were able to get your GitHub repository set up lightning fast, impressive. Job.
CD.
CD, yeah, okay, yeah, we'll start with that. Cool. CD is what?
Change directory.
Change directory. All right, let me pull up the class Google Drive. And so in here, vol you don't have access yet, send me a request for this. Get you access. And we've got a resources folder. And in there, I've just got like some notes here. And we can fill these out as we go. So here's what I've put in there so far: echo, CD, and mkdir, right? So yeah, CD, change directory. This little tilde, what's it represent? Home, yeah, that's your home base for whatever computer you're on. So when you log into the HPC, you're using the supercomputer, their home will be a different absolute path, but that's always the shortcut and relative path. We use echo once, it just regurgitates what you said onto the screen. So whatever's in the books gets put there. That seems useless, but you'll see it's actually pretty nice. Redirect those. And then mkdir, make directory, or some others. ls. So that's list stuff. I can see like stuff where you are. Yeah. PWD, which is print working directory, or where am I? What's here? Okay, so we've got the dot, dot. These are special directories. Dot means what? Here. And dot means one back. Call that the parent directory. But yeah, it's the one back. Okay. So if you're trying to get around in your terminal, you want to go back up one level, it's just cd space dot. You want to go to where you are, it's cd dot, and that does nothing. What about but where exactly? Where are we going from here? Back forward. I just threw in the dots there and mess with you. Let's say the dots, right? So we're going up 1, 2, 3, staying here, and then going up. So if we're in our terminal, and I say ls, I see the stuff that I've got set up here. Your task for last time was to think about, not necessarily to do, but if you did, that's awesome, but to think about what structure you want for your biocomputing repository. I'm going to do ls space -l to list things long, and that L is called a flag. ls-a lists all. That'll show even the hidden stuff. So anything that starts with a dot. So there's my .git folder. .git ignore. ls-a and L next to each other. Long and heavy. So we can chain these flags together. And there's a lot of them. You'll probably accidentally memorize like 3 or 4 flags for every program that we use. So there's help files, ChatGPT to get you through the other 60 options for everything. All right, so I'm looking around. I'm just basically said, hey, where am I? And that is what kind of path? Relative or
Absolutely.
absolutely? How do I know it's absolute?
Goes all the way to having the relative.
It starts at root. This backslash is root. So if I say change directory to root, that's the absolute baseline of my computer. Everything in my computer lives somewhere within this, and it's just nested folders within folders all the way down. And so PWD says, hey, you're at root, ls, A and L. Here's all the stuff. You will see different stuff in yours. I would encourage you to not go to this place very often until you know what you're doing. Again, the caveat is we're learning something that has great power. Great power comes great responsibility, or the other quote is tools sharp enough to be useful can cut you. So you can absolutely do damage to your computer here and have to wipe the hard drive and reboot it. So I'm going to get out of there by just saying CD, which will take me where? Home. Yeah, CD with nothing just takes you home. And there I am in my home, the absolute path to my home. I look around, see a bunch of crap. But one of those directories is desktop, so I know I can go in there. Capital DES, and then tab is my magic autocomplete. And then inside my desktop, I know I've got a directory called Git repositories. And that's where I have stuck my biocomputing. Get right back into it. Look where I am. That's the directions to my biocomputing from my root. Now, some of you may have made your own Git repositories. Some of you may have just put this in your desktop. Some may have put it home. So quick poll, where have people decided to stick cloud computing? Home? Home? User? Okay. Don't be shy. You find yourself thinking, I'm not sure where I put that. Anybody? Okay, yeah, so it's fine. We're going to break you of that habit, though. It's the point of this class, is that everything does live somewhere, and so it's good to start thinking about where stuff is in your computer and start thinking in terms of the file path structure. So I want you to find it somehow, whether you use your magic like Finder and search for biocomputing or whatever. You can usually in Mac right click on it and say like open in terminal, and it'll take you right to that directory, which is a neat little shortcut. But I want us all to be in there. In biocomputing thing to make for assignment 0 directly. And I'll list everything long ways. All right, I've got assignments, group project, lessons, perspective manuscript. That's just for the grad students. Quizzes and resources. I've also got a readme.md. The MD is just shorthand for markdown type of text file. Then I've got a .git folder and a .git ignore. You should see at least a README and a .git if you did first assignment correctly. Yes? All right, yeah, let's get to it. You'll have to do the dash A if you want to see the hidden dot yet. Beautiful. Do the ls dash A. Boom, there it is.
Yeah.
Lovely. Excellent. Right. Let's see here. Determine, sorry. Excellent. So you there by really. It's chisel that on your arm. No, you'll get it figured out. You already memorized it. Yeah. Oh, okay. There's only one circumstance in this class, this is worth stopping for, where you should be scared of being wrong, and then that's when we're using the RM command, the remove. Other than that, being wrong is like very normal and encouraged. Error messages are a happy thing. We celebrate whoever gets the best errors. It's okay. This is a spot for failure. Okay. Yeah.
So I had to go back and try to do
The get off.
but when I did it, it told me that I was already signed in, so then I had to push some things back to my gift. And then it asked me to say who I was again,
Okay.
so.
So you see, it's like, hey, you need to run. Oops, on touchscreen. You need to run that. So just copy that line and then change that to your email address that you use for GitHub. And then copy that line and change that to your exact like GitHub user ID.
Okay.
And then just run each of those. And you only have to do it once for this computer.
Okay.
Yeah. And remember, Control C, Control V doesn't work. Yeah. I think it's Shift Insert for Macs. I don't know. Mine's Control Shift C and Control Shift V in the terminal. All right. Oh, yeah. Let's see. Oh, you're in PowerShell. Did you download Git Bash?
Yeah.
Yeah, open that one instead. Yeah. Use that. Windows has its own version of the shell, and it's just dirty and wrong. Yeah, it only works on Windows. So yes. So now navigate there with that terminal. You've got the .git and the README. Excellent. All right, I saw some of you have other folders in there that you made, some don't. But now's the time to make them using that mkdir. And the one that the only one that I'm gonna like tell you how to do specifically is assignments. Because that way I can know exactly how to find where your assignments are when I go to grade stuff. It needs to be assignments, all lowercase. And inside of it, assignment 1 through 8. Now I'll show you a shortcut how to make all of those folders. If I go back up here to biocomputing, I can say mkdir, and this program also has a bunch of flags. One of those is -p, and I'll show you the help files here in a second. -p means make parent directories. So it allows you to like say 1, 2, 3. And that'll make directory 1, and inside it will put 2, and inside of 2 it will put 3. Okay. The P flag lets you do that, otherwise it won't let you. And so I could say make assignments / assignment underscore, and then we just need 1 through 8. Well, here's a magic trick. Curly brace, 1.8 curly brace. So this is your first real magic trick in the shell. It's called brace expansion. So you'll hear me say that term, you'll see it in help files, if you're asking GPT for stuff, it'll say use brace expansion. This is what it's talking about, is that inside of curly braces, for a lot of programs, you can either give it a range with like 1 to 8, and it will just understand that's the numbers 1 through 8. Or you can put stuff with separated by commas inside of there. So if I were to make this, what directories would it make if I were to just run this right now?
Assignment year and assignment mom.
Assignment year and assignment mom, and those would be inside of the assignments directory. I'm gonna go ahead and do that. You don't have to make your mom, because I've already got 1 through 8, so it's gonna give me an error. And then if I ls everything assignments, I can look inside of that directory. And there it is. I've got 1 through 8 and mom and your. So if you wanted a quick way in one line of making all those assignments 1.8. And that'll work 1 through 800 or 8 million or whatever you want. So that should make it for you. Now, other than that, I don't care what you put. As long as you have your README file for the main biocomputing directory, and you've got assignments and inside assignments underscore 1 through 8. But what do people want to put in their directories? This is for you, not for me. So
Like notes.
yeah, so notes. I would like this to be a spot where like the entire class, your entire experience in this class is kind of contained in this one folder. So yeah, so a folder for notes, and then you might have notes for lessons 1 through 8. Maybe just a separate file on each one of those, or maybe you want a separate directory for each one with lots of different notes files.
That also made it up to.
Practice. Yes. We do have some practice stuff on the Google Drive. Extra little things there.
Mine, did it work, it's just same for each one of those, so it's not.
Oh. Let's see. Oh, you need a little dash B. I forgot to put it there again. Yeah. Yes.
You said for the main part, is it this part, like, excuse me?
Yeah, Rosie LGA. Capitalized just like that. Yeah. Yes. If you have that. So the reason it's saying I can't get there is you don't have a folder called Git repositories in your phone. So if I do ls, see a bunch of stuff. Where did you put your biocomputing? Just keep on. Think so? Yeah. You should be able to scroll up. Let's see if it's in there. I don't see it. And so it might be in your desktop. But you can just hit the window key and type in biocomputing. See if it'll find it for you. Oh. It's searching the web. Damn it, windows. Right, so wherever this happened. You still have your PowerShell open? Okay. Because you were there in your PowerShell.
Yeah.
Alright, so can you get back to it in PowerShell? It'll be the same directions. Okay, C users are. So try LS here. Where you did the get clone. But we can try it that way. You have your GitHub page. Up. You can copy the directions there, so you can copy that. Right, then open your Git bash. This is the one you're always going to be using. And it looks like your home, so do pwd and show me where you are. Okay, so it's root C users are. And you can say git space clone, and then space, and then paste in that link you copy. But Control E won't work in there, so you can do Shift insert. Right click and paste. Okay, so now you've got your biocomputing in that path. Root C users. That's where it's going to live all semester. Okay, so now you should go into it with CD space and biocomputing. Have to be in all caps. Yeah. There you go. Okay, now show me what you got. LS. Okay, just to read me. Give me an LS-A. Gotta have a space. Yeah, perfect. Oh, dash A doesn't. Just out of that LS, yeah. And that's what I'm looking for, is that hidden folder called .git. So perfect. That means it is a Git repository. You've got a README. But now I need you to make assignments with that. Okay. Yes.
Question. So last time we made, like the assignments structure, and then we made like the assignment one, and then I like added in like the 1 through 8 also, but then.
Oh, do you have like an O1?
Yeah, so,
Okay.
and then in the O1 lesson, we did like the data output scripts. Maybe, so then should I just get rid of?
No, I'm an idiot. I meant to put leading zeros on all of these. Not just the one. I do want it to be O1, like we did last time. So that would look like that.
So is there a way to like get rid of? Like I
Yeah.
didn't do the dash P, but I like I did it like the your mom one, but then I think it made the directories, like if I'm looking at it in Finder, it looks like it should, but is there like a way to like get them all to like go away kind of thing, or should I just delete these and then?
Yeah, but let's do it through the terminal.
Yeah,
Yeah. I mean, you could just highlight and delete those, right? But where do they go when you do that? Recycling bin. Okay, when you click on a file in your Finder or Windows Explorer or whatever, and you hit delete, it does not actually delete it. It goes to the recycling bin. And on your hard drive, that file is actually still where it was, and that's how you can always say restore. It just marks it as not deleted anymore. So, yeah. This is the most dangerous command. This is the one we should worry. Because unlike clicking on something and hitting delete, RM, remove, does it instantly and permanently. It does not ask questions. It doesn't say, are you sure this is like really important? I don't know, man, like that's an important file. No, it just does it. Right? And it's gone. The FBI could probably recover it. But you cannot. Okay. So RM is removed. Use this with great caution. Here I see that I've got file 1 and file 2 that we made last time. I'm going to remove file 1 and file 2. They're gone forever. To remove a directory, there's a little extra thing that you got to do. Oops. So I've got assignment 1, 2, 3, 4, 5, 6, 7, 8. This is just another flag, a /r, -r. So this means remove recursively. So that directory and everything in it instantly, forever.
What's the RM?
Force remove. Yeah. So I can remove all my assignment 1 through 8, the ones that don't have a leading 0. And assignment your and assignment mom. And they're gone. You'll be able to look around and there I just got 1 through 8.
And then so to make, and then they're just gonna like create different ones, so then it's like, it's the like directory, and then it's then like, oh gosh.
For what are you gonna make?
Like they make the directory like ones,
01 through 08?
yeah, or I guess like count 2, 3.
Oh, yeah, so that would be, I'm hitting the up key. I should have told you this
Oh.
sooner. Up and down, go through your history. Very handy. So up, there we go. So you would just say 02 through 08, but it depends on where you are. Are you in your assignments directory already?
Yeah,
Then note this, I don't want to
Yeah.
say assignments 2 through 8.
okay, so then it's supposed to be clear. So you can like create that parent directory like through assignments or like,
Yeah, so here I
Like,
wouldn't
by-
actually need the key
okay, so you don't need it, so you only would need the key if you're starting from,
from a directory that you're not in.
okay, so if I was like doing it from the biocomputing. You have to use it.
You have to use the key, yeah.
Okay.
And that just lets it create parent directories. Yeah, up and down, very handy. Also tab complete, very handy. Use those. Okay, assignment 01. I'm gonna go in there. And what did we make last time? It looks like I've deleted everything. Everything? Read it, output, and script.
Yeah.
Okay. Here's another one that we learned, touch. What's it do? It'll create a blank file
The last time.
if it doesn't exist. Update, timestamp. If it does exist. Yeah, so I'm gonna touch rename, it just makes an empty blank file. And then we had, what was the other stuff? Data output and script. Data output and scripts. So I'm saying in KPIR, data, output, scripts. Now, some of you will have the tree command, some won't, don't worry about it. But this shows you the structure of a directory, which says, yeah, you've got data, output, a readme, .md, and scripts. Yes.
Yes, I know you just did it with the tree, but is there a way to tell like to see like what is a directory versus what's a file if you list them like that? Like for my, like just as like data output readme MD and then scripts.
So if you do ls-l,
Yeah.
does yours not color it?
No,
Okay. We'll fix that for you. The coloring is nice,
yeah.
but here's how you tell.
Mm.
LSLH, human readable. Directories are 4 kilobytes in size, almost always. Which is 4096 bytes. The other way, ls-l, if you look over here,
Mhm.
all that garbage there is about permissions, and we'll deal with that later, but it starts with a D, directory. Yep. Okay, so we're using NKDIR, we're using LS. You've seen a few flags, the A and the L flag, now you've seen the H flag, which just puts file sizes into human readable. We're used to seeing kilobytes and megabytes and all that. Without that, it just shows bytes. So the most common that people actually want is not LS, because that's just like all on one line. People actually want everything human readable, long form. Now it sucks to have to type that every time. And so today I'm going to set you up with an alias. I just say LL, and it does all that for me. So we're going to get an alias for you for that. We're going to get an alias for you, which is up.
How old is it?
Yeah, it won't. It won't yet. We haven't set it up, but we will today, promise. You won't work for you either, but it's my magic alias for go up one, clear the screen, and show everything nice and tidy. If I'm in assignment 1, it's going to go up to assignments and show everything. And then D for down, go back to where you were. So U and D makes navigating this real fast. Those are aliases, and we'll get there in like 15 minutes. So when you see me type LL, know that that's just LSAHL that I'm too lazy to type out. Okay. Questions so far, especially about file paths or what the hell we're doing, or what is the point of all this, or any other questions? I'll pause and let you think. Happy?
Are we to go over how to like edit the markdown files today?
I want to make sure before we do anything new. Now is the time. If there's any part of this that you're like, I'm not comfortable with what we're doing. No shame. This is weird stuff. But yes.
So at the end of the last lesson, we had to like add and push all this to
GitHub.
GitHub. So does everything we do get put on there? I know it's mentioned that some of the stuff that won't be covered, or wasn't like the data something.
So when you push to GitHub, and we just made these like folders, but they're empty folders, right? These directories. So when we push to GitHub, they won't show up on GitHub because they didn't have a file in them. That's it.
Hmm.
But they're actually there, it just like won't let you click on them. In GitHub, because there's nothing to see. And that's okay, it's just a idiosyncratic thing about GitHub. So it doesn't like empty directories. It tolerates them, but it doesn't want to show them off. All right. Well, hopefully this has been a nice little refresher from last time. Nothing too new. I want you spending some time just doing this stuff. Making directories, trying out that brace expansion thing, make folders 1 through 100, and then delete them all. Dig the ditch and then fill it back in. There's a reason for it. It's getting you kind of that muscle memory and comfort. Right now, the biggest inhibitor to you learning this stuff is lack of comfort with the system. Promise, because this is not rocket science. It's not partial differential equations that we're doing in this class, right? We're just like CD, LS. Okay, but it still feels uncomfortable, I know that, and like you could totally screw your computer if you hit RM on the wrong file. Stay inside of biocomputing and it won't matter. You could delete the whole thing. What happens? You just clone it from GitHub again, back to where it was. So permanent damage is not possible here within biocomputing. So if I am here in biocomputing, I just want you trying this, just make directory test 1 through 1000. Why not? Oops. Well, I polluted the crap out of my biocomputing. Easy enough. Remove recursively test 1 through 1000. And they're all gone.
I tried doing like the comma one, and I got like a thing that says like parse error near.
So was it like this?
So I did like make directory dash e, and I just like throw a slash over there, and then like just say that in the curly brackets, bro comma what, bro comma space what.
Space.
Okay.
Yeah, there you go. The space. Spaces are no-nos.
Okay.
There's test bro. That's okay. Remove recursively test everything. It starts with test and ends with anything. It's gone. Okay. So I'm back here. It's nice and clean. I've got assignments, so I can LS, AHL, or ALH, doesn't matter what order. My assignments, it shows me I've got 1 through 8, the lead is 0. We're all happy. Right. And I guess this is a good time to talk about naming files. Spaces are bad. We've got in our lesson. So here's lesson 1. We got through most of it at this point. Yeah, leading 0. Okay. Naming files. Again, this is now part of your religion. Spaces never ever go in file or directory names. That's over with. The part of your life is done. I don't want to see it. If there's a space in a file name, I won't grade it. Okay. It's really bad because the shell interprets that as 2 files. I know it's kosher to do that in Windows and Mac, They like spaces and file names, but they're like backtick coding everything. It makes coding really difficult. We want to avoid it. When we get on the HPC, spaces and file names will not fly. So we're done with it forever now. I strongly prefer the underscore between little bits of information rather than the camel case where people just capitalize the new first letter of each new word. Because this allows us to programmatically access bits of our files. We can split this whole name on underscore and just subtract the second thing from the third thing. We can't do that if it's camel case. So file names should be informative without being too long. And they should tell you what the file is, what the directory is, not how it's made. File extensions. In Windows, if you have an XLSX file and you double click it, what happens?
Like,
Mac too.
the Excel is open.
Excel open, like suddenly the Excel program is open and now your file is being viewed. Okay, Windows and Mac use file extensions to tell their operating system what program to use to open a file. But it doesn't actually change anything about the file, the contents, and it means nothing. So file extensions, we have readme.md. That could be anything, and it's still just an empty text file. I can touch your mom.xlsx. There it is. If I double click that, Windows would try to open it with Excel, even if it was not an actual spreadsheet file. So in the terminal, file extensions mean nothing. So keep that in mind. What they're for is for you, the user, and for other users to try to tell them what file type it is.
So like, this is like from my own experience, but like if I just like made a file like touch something.py, would that file not automatically go Python?
No.
No.
No, it's whatever is in that file. So when we're going to edit our README today, and you'll see that every file is actually just plain text. Some of that plain text is ones and zeros, and that's the binary files. Like when you click on Excel, that's a binary, but it's stored as ones and zeros. That's it. Computers have a very boring language. 2 words, 1 and 0. And so every file in there is that. The shell will try to interpret that as a text file. There, the word hello is that binary. And it's just a bunch of ones and zeros. Every letter, every character on your keyboard, it doesn't matter if you have an Arabic or Chinese keyboard, it's still represented by 8 ones and zeros. And so when you have a binary file or like a zip file or something weird that's stored as ones and zeros, and you try to display it in your terminal, and it gives you like all this gobbledygook, that's it just in trying to interpret as if we start with here, the first 8 or that character. Okay. So that's it. And capital H is different from lowercase h. Let me see if I can show you an example. All right, I've got a readme.md here. Show you a new command called cat. Cat just barfs up at the contents and concatenates them together and puts them onto your screen. I remembered this at first because cats puke all the time. So it pukes it up onto your screen. There's the contents of this particular README. it really is just plain text. It peeped it up to the screen for me. But here's an HTML. Woohoo! So that's also just plain text. HTML is pretty gross language, as you can see. All right. NWK, anyone know that file extension? Any evolutionary biologists? It's a Newick file format for displaying phylogenetic trees. And that's what it looks like. It's just a bunch of nested commas and colas and stuff, but that's a phylogenetic tree. It's still just plain text. All right, here's an R data object. Whoa! Binary. And the shell tried to interpret all those ones and zeros as characters, and it gave us wing names, right? Because they weren't meant to be shown as characters. It's a binary file that means something in context, but it's still honestly just ones and zeros. So not good for looking at. Totally gross. Woo! Okay. So everything is a text file, and for the most part in here, we're going to be working with DNA, RNA data, protein data, just text. Let's go ahead and do something for our README file. What kinds of things do you think should go in a README?
With the Git repositories.
Yeah, what the Git repository is for. So when you go on your GitHub, this is what's going to show right there. Right now, if I go to GitHub, find repositories, biocomputing. So I've got some contents there. You probably just have the word biocomputing showing up. That's because that README file is just being displayed here in Markdown format, which allows you to do bold text and that kind of thing, even if you're using plain. If I click here and edit this file, don't do this. Don't ever do it. You'll see that it's just plain text, biocomputing, and I've typed some stuff. I made this bold by putting 2 asterisks around it. Nothing fancy. So if I say cat README, there's the contents of mine. You'll probably just see hashtag biocomputing. So we want to put some content in there. Time for a new command. Well, let me go ahead and record cat before I forget. Concatenate files and display to screen. If I can cat multiple files and just stick them all together and mark it up to this. Time for nano. Nano is a built-in text editor. Anybody used Vim before? Isn't it horrible? Yeah. Vim, okay, don't use it. Unless you are a real comp sci geek and you're going to be like a software engineer for life, then might come in handy, but it has its own programming language just to edit text. Nano, very straightforward, lets you type, save the file. Great. So Nano works by saying, I'm going to edit readme.md. It'll open it up for you. And that's it. It's just showing you the contents. Your mouse won't work in here. I'm adding new content. So go ahead and put what you want in here for your README. I don't care what you put right now, but we're gonna use this as a way to like push to GitHub and make sure that's working. Anyone planning on applying for like internships or grad schools? You gonna have a personal website when you do that, so you can showcase some stuff? The answer is yes. And one of the things that you're gonna have there on your CV is a link to your GitHub account, so they can see some of the stuff you've done. They will click it. I promise you. That's what happens. Because people are curious, and so they're gonna snoop on you, and you want them to find not your drunken 15-year-old pictures or whatever. You want them to find your GitHub repository with some nice professional looking stuff, and so they will probably see whatever you put here is going to pop up on your biocomputing. So you don't have to make it perfect right now, but just keep that in mind that this is public facing. So I'm adding some new content. I just put a new line. And then when I want to save this file, there's no Control S to save. Instead, at the bottom, it's actually showing me the little shortcuts. Control O, that's the little caret, is write out. That writes the contents of this into the file. So Control O is the save. Write it out. And it's gonna say name of the file. Well, yeah, readme.md, that's the one I'm trying to save to. So I hit enter. And then it's time to exit. How do I get out? Control X. Right, so that's the basics of Nano. It's a Nano, and then the name of the file you want to mess with. You type some stuff, or you edit some stuff, remove it. Control O, enter. Control X. Yes.
Is there a way you could like see like how the markdown actually looks like in the terminal?
You'll have to install a program called CanDoc for that. But that converts Markdown or HTML or a bunch of different Markdown languages. HTML is just a markup language, hypertext markup language. It converts it all to PDF or Word documents and documents. So it converts everything to everything else. A nicer way is just get online and say Markdown preview, and this is the one. This shows you what things look like in Markdown on the left, what they will look like on the right. And so asterisks give you bold, single asterisks give you italic. You can make things look. It's not like LaTeX or anything where it's completely customizable, but it's pretty clean and straightforward syntax. 3 underscores give you one of those little like nice lines across the page, like a little page break. So the Markdown previewer is how I usually do it rather than CanDoc. All right, so we've got our README. That means that we have a new file changed in our GitHub repository. How do we investigate the status of our Git repository?
Git status.
Git status. Okay. So it's noting that I did used to have assignment 1 without 0 and some test files, and I deleted them. Yeah, I want them gone. Oh, shit, I actually want those. I can get them later. Let's see, that's the nice thing about GitHub is that, yeah, I deleted these files, but they're actually still on GitHub, so I can just get them back. That's fine. Okay, so it's got my modified readme.md. You should see that. If you don't, let me know. Already got modified there? Okay. We want to push it to GitHub, which means we have to do 3 things. Here's your get things, add, commit, push. And this is trying to show how it works. You've got your working directory here. If you make any changes, you can put them in a staging area by saying git add. Puts them in the staging area. Then git commit memorizes them. Okay, so it puts them in the warehouse. And then this is online. Git push pushes them online. Git pull would bring any changes down that you or somebody else has done. So add, commit, push. Git add. And the shortcut to add everything, like all these changes that are listed in red for me, git add dot. Why does that work?
It's where you want.
Yeah, add this directory, like add everything here. Then if I say git status again, mine are all green, and they say, okay, changes to be committed. Right? Now what? Git commit -m, and then in quotes message. I'm gonna just say update readme. Just a little quick note to tell you what you did, because you can search through these later. Okay, now what? Git push. So the changes that I added to my staging area, committed to memory locally, I'm now going to push online GitHub. Boom, boom. I failed. What about you? Now I succeeded. You guys okay? Did it just push? Fine. What happened to me was that on a different computer, I had made some changes to my GitHub repository, and I hadn't pulled those changes to this one first.
Like on your local, you can have a local here.
Mhm. I have like 5 freaking versions of biocomputing. Home computers, on my phone, on the Git app here. Yeah. That's a mistake. I'm stupid for doing that. Try to keep it on my computer, but that's how I fixed it. It's like, oh, okay.
So is
Pull
that
stuff
thing
first.
pulled from the staging directory then?
It's pulling from my main branch online.
So these are, all these changes are on main already?
Yeah.
But the changes that are locally, like, so say like on your phone, right, you have like something that you changed, you have to rebase it. That's on your phone,
So yeah. Okay. So now on my phone, I'm gonna have to do git pull also to get all the changes. So not a big problem. Okay, so and it tries to explain it pretty well, saying like, hey, I rejected your updates because the remote online contains work that you do not have locally. So I had pushed from another computer, not pulled this. Well. Sanity check, you go here to your GitHub repository and you refresh it. And there, I see my new content. Happy? Got stuff. Oh, I'm happy.
What's the this?
Oh, yeah, I never even opened that file.
Okay.
Yeah. Go ahead and click it. Let's see. View raw.
I asked ChatGPT about that yesterday
Okay.
because it was showing up in Instagram, and it's like. I think it's something with Max, I think like that's what we used and use it to get rid of that.
Well, it's there. It's not gonna hurt anything. Okay, so no changes added. So you gotta do, it's saying you need to add, so git add space dot. Yeah. Yeah, just a dot. Yeah. Yeah. And then get commit M with your, like the dash M and then a quoted message of some sort. It's gotta be in quotes. And get a check of it. We'll do it now anyway. All right, do nano. And then, yeah. And then write some stuff. And then control O. Mando, yeah. Oh, control O. Yeah. Enter, save it as that, yep. And control X. Great. Now git add dot. Git commit. With a dash. Let's whatever message you want. Yep. Okay. So you need to, this is what I wanted to do. So that looks good. So then git push. Beautiful. So check it online. Good. Ooh, oh, this is good. You got stuck in there because you forgot to get in the quote.
Yeah, I never forgot to start over. I'm not good.
Yeah, how do you get out? Let me show everybody because you're not the only person that's gonna happen to. It happens to me like all the time. I'm typing some stuff and I forget to close the quote and hit enter. And it changed my cursor to this little greater than. Dawn is the little dollar sign that I know and love. And I'm like, LS, what? PWD, shit. CD home, nothing. It's still waiting for me to close that. Control C is my get out of jail free card. It just stops whatever was happening, puts you back to where you were. Yeah. So this will happen to you, I promise. When you see that little greater than and it's not understanding your commands, just control C. In fact, I'm going to add that to our notes here. All right, so that cancels any command. So my new content showed up. Looks like everyone else got theirs. Here, did yours pop up with its random garbage? Your GitHub page?
It's not like on the.
Oh, so you had it in README in assignment one. Oh, that's okay. No worries. So your original README, eventually I do want you like editing that to be public facing. Yes, question. Okay, so this is a one-time only thing for this computer. You need to copy those lines, changing that to your actual email that you use to GitHub. And then that one to your RP 703 and just run them one at a time, and you won't have to do it again. Yeah. So go ahead and do that, and then it will let you do the push. Okay, what's the confusion and frustration level with Git? Okay, we got one for feel pretty good, not too bad. If 10 is I'm gonna cry in my pillow right after this class, is anyone like pushing a 7 or 8? 5? You're just too afraid to say. My current frustration with Git is about 5, 6 right now. And that's taken me years to get there. The more you use it, kind of the worse it gets. And when you start using it with other people and you're both pushing to the same repository, this is the stuff of nightmares, but that's how it works. Because you'll both try to push changes that are incompatible. You're both working on the same code base. There are ways that we can like make this nicer that we will make sure to deal with when we do our group projects. We're all going to be working in shared Git repositories. But if we stay in our own folders in there, none of our changes will be overriding each other's, and that kind of keeps it nice. And so it's just about being a good citizen that makes GitHub work. But when you work with somebody who's not a good citizen, awful. You start having divergent branches and that way. So yeah, Git is a lot, but it's how you're turning in your assignments. And it is also, I promise you, how you're going to get that internship you've been wanting. Because this is how the industry works. Use GitHub. Few weird companies out there use like Mercurial, which is an alternate, but almost everyone GitHub. Every now and then GitLab. So it's just something you're going to have to get used to. You're paying your taxes right now in frustration, and it will pay off because it's really nice. For instance, I deleted those R scripts that I actually really wanted. Okay, well, I can click up here. I've got 8 commits. I've got this history. I can click on them. And I can see all the old versions of this entire repository. Here's one from 5 days ago. One file changed, I just added test. Okay. Well, I can go to that version of the repository. And see the different changes that were made. So this README. Did I actually not push it? No, there it is. Add assignment 8 files. Look at that. My commit message was actually meaningful. Good for me. And so there they are. I can easily download this again. There's ways to do it in Git, but we don't want to go down that path yet. Got a few minutes. You have an assignment that will be due Thursday before class. It's not difficult. It's assignment 1, but I want it done and I want it pushed to your GitHub. Put it right here, assignment 1. And it's more of a reflection kind of piece. We've got our optional textbook. I'm allowed to post 1 chapter for free, so there you have it. This is the best chapter, I think, for us getting started. I want you to read this chapter a couple times. And it's philosophically why we're doing this, why you're taking a class to learn this arcane command line that was invented in the 1960s. It's still in use. And it's to get you thinking about this idea of reproducibility. So assignment 1 is to read that, reflect on it. In your assignment 1, right? Assignment 1, I want you building a nice directory structure and adding a placeholder file into each one of these so that they show up in GitHub. So just an empty example.txt or file 1, whatever you want to put there. And you must have this file, assignment 1 essay.md. That's going to be your reflection piece. And then readme.md is going to have all the commands that you used and all your notes for the assignment, things that you were thinking of, all the commands that you used to make this directory structure. So that mkdir, that touch, all that. Every time you get one you like, save it in a text file, put it in your README so I can see what you did to make this. And then I can go to your assignment 1 essay and look at that. So we're documenting work. That's it. Push to GitHub. So I've got local copies of all of your repositories. You've sent me your link now. And so I can just say git pull, and suddenly I have any new files that you push. And I've got a script that goes in and automatically looks for things called assignment 1 essay. Yeah.
So for the documenting your work, like do you want like only the commands that we use, or do you want to list like all of the ones?
The commands that you used and liked.
Okay.
Yeah, I should be able to redo each one of those commands in order and get exactly the same directory structure that you got. That's the hallmark of reproducibility, and documenting it in README is how we're going to start, and we're going to learn how to build scripts that do this automatically here in a few weeks. But right now, just put them in order, like mkdir, assignment 1, whatever it was that it took to get things. So I should be able to copy and paste those and run them and get exactly what you've got there. Yeah. So there's that. And then your other assignment is to send an email to HPC help at wm.edu. Here, I'll just do it in the app. And in here, I want you to tell them that you're in Applied Science 460/691. Okay. And I want you to tell them that I want a bash terminal, not ECHFH. And then give them your 93 number. HPC account, please.
I already,
Great, then you don't need it.
I don't know if it's like terminal, there's no.
The default is T shell.
Okay.
So send them a help message and say, I want my default terminal to be bash on all clusters. And don't just send this literally, I mean, turn it into like, these are actually humans. All right. So you're going to request an HPC account. You're going to tell them it's associated with this class, give them your 93 number, and tell them that you want bash. They have the HPC set up for this older shell, TSCH shell. And that's because the people who first designed this were like working in C++ and Fortran and these like older languages, and they're doing astronomy, which apparently still uses Fortran. And that shell is designed for that, but it's not commonly used anywhere. We don't want to bother learning it unless you're going to go into astrophysics.
Can you set what if you're logging, if it's bash?
Yeah, I'll show you how. Echo $0.
No.
Yeah.
Yeah.
So they're really quick. They're wonderful people, and they're like on it, and they do good work. So within a day or so, you'll have that in the next session on Thursday. I anticipate that we're all going to be logging into the HPC. We can really do some damage. It's going to be fun. In the meantime, go ahead and do assignment 1. And hit me up if you got any questions. Shoot me an email and pop by my offices across the hall. Yeah. Oh, yeah, yeah. You send me an email? Please, yeah, that way.
Oh, yeah.
Yeah. You have the link to the, it's in the. So you can click the drive link and say request access. Yeah.
So, I wanted to like,